Good evening, everyone. In our last two videos, we have covered the program TwoSum in topic arrays and hashings. Today, in the same topic, we're going to look at our next program, contains duplicate. Today, we're going to cover the brute force method of contains duplicate. For those of you new to my channel, hi, my name is Reshmita, and I'm a computer science graduate who posts lead code videos as a hobby. I have done a complete introduction of this video series in the very first video of this playlist. Now let us get to this problem contains duplicate. Now let's read the problem description. Given an integer array nums, return true if any value appears at least twice in the array and return false if every element is distinct. We have three examples over here out of which we'll look at one more closely. And here are the constraints. Firstly, about the list size, and secondly, about each element's value, what it could be. Firstly, we need to understand what the concept of a duplicate is all about. A duplicate is basically when the same value in any data structures appears more than once. That's when it's called a duplicate. We need to say yes or return true if a duplicate is present in this program, or say no or return false if a duplicate is not present. That's the main objective of this program. We have our first example in example 1. By looking at the list nums itself, by that we can see that there's a duplicate which is number 1. But how do we figure out the answer using algorithm so that we can deal with very long lists and solve it in the computer? That's when we come up with the brute force method of this algorithm. The brute force algorithm is the simplest algorithm for humans to come up with a math or computer science problem. Let us now visualize our list. So this is our list, which is there in the test cases, there in the program. Here are the list elements, as well as the list indexes. Now think of what we can do. Think twice. Think twice of what we could do to solve this problem, which is the simplest way to solve this problem. We could check each element of the list and check each element towards the we can check each element of the list and check each element towards the right of that element, whether it's the same element or a different element. If the two values are same, we could say that yes, there's a duplicate. If not, there's no duplicate at all. Let us show this visually. We have two pointers, left and right. Our left points towards the leftmost element, which is there, and our right pointer points towards the elements towards the right of that element. So we iterate our left pointer step by step, one by one, throughout almost all the elements in the array, and we iterate our right pointer step by step, one by one, throughout almost all the elements in the array, which is like the left of the element that we're checking right now, which is towards the right of that element that we're checking right now, not left. So now let us see what happens on each iteration. At first, our left pointer points towards index 0, our right pointer points towards index 1, and then we move our right pointer towards the right. Since these two are not same, we move the right pointer towards the right. And then since these two are not those two are not the same, we move our right pointer towards the right. And as we can see over here, these two are same. So hence we found our duplicate. So since we found our duplicate, we return yes, true, there is a duplicate. So now let us build our code step by step, one by one, based on our brute force algorithm that we planned out. Alright, so first we initialize the list and outer for loop. First we need a list to check for duplicates. We start by setting the outer for loop. This loop will iterate through each element in the list from the beginning. We'll stop one element short of the end because the inner loop will handle the final comparisons. So this is our program. This is our nums list. This n checks the length of our list. For I in the range of the length of list, so I will iterate throughout like the length of throughout our list. So then we need to print the index along with the index's value. So let us run it and see how it works. Index 0 with value 1, index 1 with value 2. Yup, it runs correctly. Index 2 with value 3, index 3 with value 4, and index 4 with value 2. Yes, it runs correctly. Now let us go to our next program, inner-for-loop.py. Here's our nums list. N checks the length of our list, and then we iterate our outer for loop throughout the list, and then we iterate our inner for loop one step right towards the element that we're checking currently, and then throughout the end of our list. So then we print out the index I, the index j, the value of index I, and the value of index j. Let us run it and see how it works. Yep, comparing index 0 with value 1 and index 1 with value 2. Comparing index 0 with value 1 and index 2 with value 3. Yep, it works correctly. So, what is the main purpose of adding the inner for loop? We add the nested loop to compare the current element from the outer loop nums of I with every other element that comes after it in the list. This avoids redundant comparisons, comparing nums of 0 with nums of 1 and then nums of 1 with nums of 0, and comparing an element to itself. So running this script would have shown you the comparison between the two elements. Next, we implement the comparison logic. So over here we have a list with duplicates. Over here we have a list without duplicates. So this is supposed to return true. This is supposed to return false. And this comparison logic is the core of the brute force solution. Inside the inner for loop, we add an if statement check whether the two elements compared are equal. If they are, we found a duplicate and we can immediately return true. Otherwise, we return false. So here's our nums list. We given our nums list towards this function. N is the length of nums. So n is equal to the length of our list. We iterate our outer for loop as shown in this program. We iterate our inner for loop as shown in this program. And then if nums of I is equal to nums of j, then that means like our duplicate is found. We print the value along with its indexes, both its indexes, because it can be found in two of these places. And then we return true. Otherwise, if we do not find any value that in which nums of I is equal to nums of j, if we don't find any value like that, then we print out no duplicates found and then we return false. So for over here, we check this list with duplicates and then we check this list without duplicates. Let's see how it works. This is supposed to return true and print out like this value along with its indexes. And this is supposed to return false. And then print out no duplicates found. Let's see how this works. Duplicate is found. 2 found at indexes 1 and 4. True. Checking list without duplicates. No duplicate found. False. Yes, it works correctly. Now let us get on to coding our final program. N is equal to length of nums for I in range n. For j in range I plus 1 to n, if nums of I is equal to nums of j, then you return true. Otherwise, you return false. After the for loop and everything's done, let us now run it. It's accepted for all the three cases. Now let us submit it and see what happens. Do you think it'll submit for all the test cases? Let us see. The time limit is exceeded. So for a very long list, and for very long lists where no duplicates are there, or even for a very long list where duplicates are there, the time limit is exceeded. Hence, it indicates that our time complexity is really very high. Now, for the time complexity, let us analyze why our time complexity is really high. Right now, let us see the number of iterations it takes for a non-duplicate for a non-duplicate list to run. So now in this example, let us take this example. List without duplicates or list without dupes. Let us first visualize the list. These are elements in the list and these are indices. Let us look. So this is basically our worst case scenario. There could be even worser case scenarios than this, but like we're taking our one of our worst case scenarios where the list could be like medium to large in size and there are no duplicates in the list. So in this case, we might have to like iterate our left pointer throughout the list and our right pointer throughout like almost every element in the list. Let us look at it iteration by iteration. Iteration 1, our left pointer is here, our right pointer is here, they both are different. So then we shift our right pointer towards the right. Again, our values are different over here, our elements are different. So therefore, since our elements were different, our right pointer was shifted towards here. Again, our elements are different. And then our right pointer shifted towards here, our elements are different. So then we shift our left pointer over here since our right pointer reached the end of the list. And then we set our right pointer to left plus 1. So then over here, our left element and our right element are still different. And then we shift our right pointer one element towards the right. Again, they're different. And then our left pointer is over here. Wait. Yep, and then our left pointer is here, our right pointer is here. So again, our right pointer is shifted. Our left again shifts and our right is again left plus 1. So then like they both don't match once again. And then our left pointer is over here, our right pointer shift towards here. So since we do have nowhere to go for this right pointer, our left pointer is again shifted once towards the right, and then our right pointer is equal to left plus 1. Again, they're different. So therefore, we have iterated throughout the whole list using both our pointers. So let's count how many iterations they are. 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10. The length of this list is actually 5 elements But we have gone through it like 10 times, 10 iterations. So therefore, it could not be constant, it could not be linear, it could not be logarithmic either. So it's none of these. So therefore, it has a time complexity of, let's let's just write it over here. Time complexity is equal to O of n. Let us mathematically now calculate it why it's O of, like, our time complexity is O of n square. No, sorry, not O of n. Our time complexity is O of n square. Let us mathematically calculate it why it's O of n square. So we have a for loop over here which iterates through almost all the elements in the array. And the inner for loop also iterates through almost all the elements in the array. N stands for the element in the array. So for each time a for loop iterates through through one element in the array, this inner for loop iterates through almost all the elements in the array. So therefore it's n times n, which is n square. Our space complexity, though, since no additional data structures are used, it's O of 1, which is actually good. Our space complexity is good, but our time complexity is not. So in our next video, we're going to look at the efficient approach for contains duplicates to overcome the time complexity problem. In other words, to reduce our time complexity. Thanks everyone for watching. I hope you liked and enjoyed today's video.